Good evening, everyone. I am Chandan, and my teammates are Abhishek, Aditya, and Aman. And we are here to present our topic real-time smoke monitoring with email alerts via Blink IoT Cloud. Next, the contents are introduction, model design, components use, and what we have done in third review, output, applications, and conclusion. Introduction. Smoke and gas leakage are major causes of fire accidents and health hazards in home, laboratories, and industries. Traditional detection systems are either costly or do not provide remote alerts. To solve this problem, we designed an IoT smoke and gas detection system using ESP8266 node MCU and MQ2 gas sensor. This system continuously monitors the environment for smoke detection and concealable gases. In third review, we enhanced the system by adding a buzzer for immediate local alerts, email notification via Blink IoT Cloud, and next working physical model with proper enclosure. These improvements make the system more reliable, user-friendly, and close to real-world products. Next, model design. Model design. This let's explain the architectural designs of our project. Uh, the ESP8266 node MCU acts as the brain of a system. It collects sensor data, processes it, and send alerts. MQ2 smoke and gas sensors detects gases like LPG, methane, and smoke. The sensor output is connected to analog pin AQ ESP8266 and where signal is converted into readable values. A buzzer is connected to a digital pin, provide an instant audible alerts when gas concentration is across the threshold. Using Wi-Fi, the ESP8266 connects to the Blink IoT Cloud platform, enabling the real-time monitoring and email alerts. This ensures fast detection and instant waiting and remote access. Thank you. Next, will continued by Abhishek.
Thank you, Chandan. I'm Abhishek. Yes, now I'll continue the presentation. Components used. Components we have used is breadboard. We used a breadboard for easy prototyping and jumper wires for component connections. The MK2 sensor is positioned properly to ensure accurate gas detection. Next, the ESP8266 node MCU is centrally placed for stable power supply and Wi-Fi connectivity. All connections were tested to avoid loose wiring and false alerts. The final model demonstrates how the system can be deployed in environmental system. The main components used in our project include ESP8266, MQ2 smoke and gas sensor, buzzer, breadboard and jumper wires, Blink IoT cloud platform. Each component was selected based on cost efficiency, availability and performance. Next, the ESP8266 node MCU. It is the core controller of our system. It is preferred because it has built-in Wi-Fi, low power consumption and supports IoT platforms. It reads analog data from the MQ2 sensor, compares it with threshold values and decides whether an alert is required. It is also communicates with Blink Cloud to send data and email alerts. Next, the MQ2 sensor. The MQ2 sensor is used to detect smoke and combustible gases such as LPG, propane, and methane. It continuously senses the gas concentration in the surrounding air. The sensor outputs an analog signal proportional to the gas level. This signal is processed by the ESP8266 to determine whether the environment is safe or hazardous. Next, the buzzer. The buzzer provides an immediate local alert. When the gas level exceeds the predefined threshold, buzzer is activated instantly. This feature is critical in situations where internet connectivity is unavailable. It ensures that people nearby are warned without any delay. Next, Blink IoT Cloud. The Blink IoT Cloud platform is used for remote monitoring and notification. It displays real-time sensor readings on a mobile dashboard. When hazardous gas levels are detected, email notifications are sent automatically to the user. This allows user to take immediate action even when they are not physically present. Next, what we have done in sorry, what we have done in third review. In the third review, we focused on making the system more complete and practical. We added a buzzer for immediate alerts, email and app notification via Blink, a proper physical enclosure. We improved sensor placement, wiring organization, and overall appearance. These enhancements make the project look and behave like a real commercial safety device. Thank you. Next will be continued by Aditya.
Thank you, Abhishek. I am Aman. I am explaining about outputs. This system successfully detected smokes and gas leakages in real time. Sensors value are continuously monitored and displayed on the Blink dashboard. When the gas level or smoke level threshold, the buzzer turns on immediately, and an email alert is sent to the users. The system works reliably under different test conditions. We used Blink for gas level executed in this. Next applications. These systems can be used in smart home for fire and gas safety laboratories handling hazardous gases, industry areas for gas leakage detection, commercial buildings and offices, kitchens and storage room using LPG or gas cylinders, educational institution for safety monitoring. This system helps in preventing accidents and reduce damages. Conclusion. To conclude, our IoT-based smokes and gas detection system successfully interrogate real-time monitoring, local alerts, and remote notification. The ESP8266 and MQ2 sensors announce accurate detections. The buzzer provides instant warning, and Blink ensures remote awareness through email alerts. The system is cost efficient, scalable, and suitable for real world applications. Thank you. Let's continue by Aditya.
Thank you, Amar. Now I'm continuing the next part. So this is the Arduino code of the Arduino dashboard. So in this code we have two libraries. One is include ESP8266 Wi-Fi.h, and another is a Blink Simple ESP8266.h. This library tells about the how ESP will be connected with Wi-Fi, and the second library is about connecting Blink with the ESP. In this code, we give our hotspot password and the username connected with our laptop's IP address. So in this main part of the code, we have set the threshold value as 300. If the smoke value exceeds 300, then we are going to get outputs as we defined here, blink log event. So yes, we will send tells the blink to send a notification to the user email address. Smoke detection, smoke detected. This alert. So next connection. So this is a Tinkercad which we use first. In this Tinkercad we used Arduino, but as per we should use the ESP8266 because Arduino doesn't have any Wi-Fi connectivity. That's why we replace the Arduino instead of ESP8266. So I am going to explain our model now. So now I have connected my USB cable with it. One second. So as you can see, the we connected USB with it. So and in the Arduino IDE part, we see the continuous output every second of the smoke value. And then coming to the blink cloud, here we have a device of smoke monitoring. It also prints the continuous value of the output. So after connection, simulating it. So you would see in the split screen. We place the smoke near the ESP, our model. You can see now, the smoke value has been increased to about 200. Once it reaches the above 300, you will get the notification in email also and in app also. I think it reports more smoke. As now smoke's intensity has been increased. The value also been started to increase. As you can hear the buzzer alarm, and when the smoke value again reaches below 300, the smoke alarms been off. Here in the Gmail ID, if I log into my Gmail ID, so till it loaded, I will open my web. Open my XC. I will start Apache and MySQL here. Then opening my local host. This is the home page of my this our database dashboard. So we created a database called Smoke IoT. In that there is a table of smoke logs. In this, it will be a continuously add value. It has columns like ID of the smoke event and smoke value and the event date, start time, and the end time. Event smoke value means how a ton of smoke it's been detected. In the event date, on which date, start time is in which time it had been started, and also at end time which time it had been ended, and in duration second it shows how much second it's been there. So here you can see at the time 9 o'clock, and you got a smoke detected Gmail notification. And now we should make sure that it should be insert a column at which the ID 6 with the smoke value and event date. So again making this smoke. Smoke value has been reached 300. Now it's above 300. I will wait for some time to make sure that end time will be sufficient. So it's been enough. And if I checked in Arduino IDEO means it also crossed above 600, 636, and 500. That's been so good. And in the local host, if I just click refresh, you can see a new row has been added with the ID of 6 and with the smoke value of 533. So smoke value, it takes average smoke value, and the date is today's the time 9:03, and also end time, and the smoke was detected for 32 seconds. So we can see how the database been implemented here. So we connected Arduino ID with the database. We made it such a way that if the smoke value reaches 300, it should send a URL. It should send a status to the local host. Like for example, if I assume if it will send this URL. In this URL, it tells smoke started has been logged. Means it detects smoke value detection is been started. And now if I just refresh it, you can see that another line will be row will be appear. It has end time of null because now it's been started. Now to end this event, just clicking the status value at 0, smoke and logged, and after just refreshing, the end time has been printed here with a duration of 25 seconds. So we now to the our database, localhost database, And from this, we understand about how we connected Apache with the MySQL and with the Blink IoT devices. In the Blink IoT devices, also, if you go to the notification center, it gives us a notification of smoke detection, smoke detected. So basically, we tried to add another user, means for others to access it. But if I just try to add someone, it does not even take it. Means and we researched about it. It said we need to upgrade its plan. After upgrading its plan, only we can add so many members to the one device. So now value has also been decreased. So this was our project. Thank you.
So why do we use ESP32?
Ma'am, we used ESP8266, ma'am.
Hmm.
So
Why?
basically, using ESP8266, if we
Hmm.
used Arduino means cannot get Wi-Fi support. We should spend extra money on another Wi-Fi adapter for it.
Hmm.
So using ESP32 or ESP8266, we can see that it had a built-in Wi-Fi support.
So what is Blink Cloud?
So basically, Blink Cloud is a virtual storage area.
Hmm.
In this, which supports the connection of IoT devices. So we can it had many Blink libraries to connect the Arduino or ESP uh, to the devices, and it has a clean interface, so users can access their notification all.
How is data sent to the cloud?
Uh, so as
How
you
it works? How it works? How is data
can
sent to cloud? Then how it can be work?
so before starting our code, we should add
Hmm.
to our Blink template or Blink token. So using this
Hmm.
authentication token, we can connect our Blink IoT, Blink Cloud. So this Blink token we get, it's like this authentication token, which is unique for every Blink user. So using that token, we will connect our Arduino, we will connect our ESP with the Blink.
Hmm. So what happens when smoke exceeds the threshold?
So when the smoke exceeds the threshold, it gives us a notification on the user devices and an email notification, and also it will add a line row in the database.
Okay. Only Aditya is answering. Others are not there. So why are email alerts important?
ಮ್ಯಾಮ್ ಬಿಕಾಸ್ ನಾವು ಎಲ್ಲಾದರೂ ಬೇರೆ ಕಡೆ ಇದ್ರೆ ಮ್ಯಾಮ್ ಅದು ನಮ್ಗೆ ಗೊತ್ತಾಗ್ತೈತೆ ಮ್ಯಾಮ್ ಇಮೇಲ್ದಿಂತ ಅಲ್ಲಿ ಸ್ಮೋಕ್ ಡಿಟೆಕ್ಟ್ ಆಗೈತೆ ಅಂತ.
Can this system work without the internet?
ಮ್ಯಾಮ್
No, ma'am,
ನೋ
it
ಮ್ಯಾಮ್,
needs internet.
ವೈಫೈ ಇಮೇಲ್ ಬೇಕಂದ್ರೆ ಮ್ಯಾಮ್ ನೆಟ್ ಇಂಟರ್ನೆಟ್ ಬೇಕು ಮ್ಯಾಮ್.
So how does Blink communicate with the hardware?
ಮ್ಯಾಮ್ ಯೂಸಿಂಗ್ ಇ ಎಸ್ ಪಿ 26 ESP 266.
Ma'am, so in this code we can see we install the libraries to connect
Hmm.
ESP to double 6 with the Wi-Fi, and
Hmm.
also to connect the Blink with the ESP8266. From this, we can connect the Arduino ESP and the Blink IoT.
So what happens if Wi-Fi disconnected?
If Wi-Fi disconnected means the system will stop, ma'am. It need internet.
Hmm. So why did you face any false alerts in your project? If any
Uh,
issue of false
not
alerts?
when if the
Hmm.
MQQ sensor hits more,
Hmm.
basically it sometimes it gives value 400, 500. So we just research it about it. So it tells the MTQ sensor is made of a coil inside it, which will be heated. So basically it will give the false information. Sometimes if the system overheats.
So in email notification, it will be some of the people it will happen, but immediate only for SMS alerts. It's the most important nowadays. So in future, it will be implement only for mobile SMS alerts.
So in the Blink, ma'am, there is an option to add the
Hmm.
alert.
Hmm.
1 second. If can if we need to add the SMS to our any contacts, it will be need a subscription, ma'am. You need to
Hmm.
buy the subscription of it. After buying subscription, we can add our mobile number to this. It also add the option for SMS. So now only we can push the notification to email of the device owner.
So if you any power supply, it will be used for a particular home or industry. It will be the in your project model. It will be fixed. So in your model with only for power supply, it will be worked.
Yes, ma'am. It needs power supply, ma'am. Otherwise, otherwise it will not work, ma'am.
Okay. So you can use only for connection through system and model. So only for working power supply, only model and power supply it will be work.
Yes, ma'am. It need a power supply and Wi-Fi, ma'am, to connect with the user's device.
Okay, thank you.